The date is mid-October in the year 2025. If you were standing inside the Mission Control Center in Houston, or the operations room of the European Space Agency in Darmstadt, you would notice something unsettling. Usually these rooms are alive with a specific kind of chaos. They are places of constant motion where walls of monitors display cascading waterfalls of numbers, where voice loops chatter with technical updates, and where the air hums with the confidence of human intelligence. Usually these rooms feel like the nerve center of a god, but today the room is heavy with silence. It is not a quiet peace. It is a tense, thick silence, like the moment before a thunderstorm breaks. The engineers are still sitting at their consoles, but their hands are resting on their laps, not typing. The flight directors are staring at screens that show flat lines or static maps. There is no new data coming in. There are no pictures downloading. There is no telemetry, the heartbeat of the machine streaming across the monitors. For the first time in 2 years, humanity is blind. This is not a malfunction. Nothing has broken. No computer virus has attacked the systems. This is an event that was written in the orbits of the planets billions of years before humans even learned to look up at the sky. This is the solar conjunction. To understand the tension in the room, you must understand the geometry of the solar system right now. Imagine a straight line drawn across the flatness of space. On one end of the line is Earth teeming with life and impatient scientists. On the very far end of the line is Mars, the red planet, currently home to billions of dollars worth of rovers, landers, and orbiting satellites. But directly in the middle of that line, blocking the view, blocking the signal, blocking everything, is the sun. The sun is not just a bright light, it is a monster of energy. It is a 1 million kilometer wide ball of burning plasma. It screams with an electromagnetic noise. It spits out clouds of charged particles. It creates a chaotic environment that no radio signal can survive. Right now, Mars is hiding directly behind the sun. For 2 weeks, usually every 26 months, the Earth and Mars play this game of cosmic hide-and-seek. During this time, we cannot speak to our machines. If we tried to send a command, a simple instruction like turn left or take a photo, the radio waves would have to pass through the sun's outer atmosphere, the corona. The solar interference would twist and mangle that message. The command turn left might arrive at the rover as a corrupted string of noise that could cause the machine to drive off a cliff or erase its own memory. So we do the only thing we can do, we stop. We enter a command moratorium. This is a fancy way of saying we simply shut up. We park the rovers, we put the satellites into a safe mode, we turn off the cameras, we leave the most advanced technology ever built by human hands sitting alone in the dust and the cold millions of miles away. And we wait. In the control room, a senior engineer spins a pen between his fingers. He has spent 10 years of his life building the guidance system for the latest Mars Explorer. He knows every wire, every line of code. But right now, he is powerless. His creation is on the other side of a star and he cannot help it. This is the irony that hangs in the air of October 2025. We live in an age of instant connection. You can video call a friend on the other side of the planet with a device in your pocket. We have artificial intelligence that can write poetry and solve medical mysteries. We have quantum computers and hypersonic jets. We feel like masters of the universe. But a simple alignment of celestial bodies reminds us how small we really are. A big ball of fire gets in the way and suddenly our super technology is useless. We are reduced to the same state as our ancestors, staring at the sun, waiting for it to move. This period is what the scientists call the cosmic blind spot. It is a terrifying concept for a species that is obsessed with the seeing everything. We have cameras on every street corner. We have satellites that can read a license plate from orbit. We map the ocean floor and the human brain. We do not like secrets. We do not like the dark. But the blind spot forces us into the day. During these 2 weeks, anything could happen on Mars and we would not know. A global dust storm could rise up and bury the solar panels of our rovers, starving them of power. A meteor could strike a critical satellite. A system failure could occur and the machine would scream for help, but its digital cry would be swallowed by the roar of the sun. The screens in Mission Control display a simulation. It is a digital graphic showing the position of Mars relative to the sun. A small red dot moving slowly behind a massive yellow circle. It is just a prediction, a guess. It is not real. Real is the static on the audio channels. If you put on a headset and listen to the deep space network right now, you would hear the sound of the sun. It sounds like a hiss, a crackle, a violent wash of white noise. It is the sound of hydrogen fusing into helium. It is the sound of raw, uncontrolled power. Somewhere on the other side of that wall of noise, our machines are waiting. The junior staff members try to joke to break the tension. They talk about what they will have for lunch. They talk about sports, but their eyes keep drifting back to the blank screens. There is a psychological weight to the silence. It feels like holding your breath underwater. You know you will be able to breathe again soon, but the urge to inhale the panic of the weight grows stronger with every second. But this time in October 2025 the feeling is different. It is heavier. Perhaps it is because the solar cycle is at its peak. The sun is more active this year than it has been in decades. The solar flares are larger, darker, and more violent. The interference is not just a hiss, it is a roar. The wall between Earth and Mars feels thicker, more impenetrable than ever before. Or perhaps it is something else. There is an old saying among astronomers, the universe does not like to be watched. It is a joke mostly, but in the deep hours of the night shift when the coffee is cold and the hum of the cooling fans is the only sound, it feels less like a joke. We have spent the last 50 years poking at the universe. We have sent our metal toys to touch the asteroids. We have sent our radio waves screaming into the void saying, we are here, we are here. We have been loud, we have been bright. We have been watching everything. Now the sun has closed the curtain. The sun has created a blind spot. And in that blind spot, in that shadow behind the star, the universe is finally unobserved. What happens when no one is looking? What happens when the cameras are off? The flight director stands up and walks to the main window. She looks up at the sky. It is daytime outside and the real sun is shining down on the parking lot. It looks so normal, just a bright circle into blue sky. It gives warmth to the flowers and light to the office workers. But she knows better. She knows it is a barrier. Status check, she asks, her voice cutting through the quiet room. Signal, still loss of lock, the communications officer replies. Solar interference is 100%. We have nothing flight, just noise. Keep listening, she says. Mars will clear the limb of the sun in 48 hours. We should get a carrier wave soon. Copy that, listening. They go back to waiting, but as the static hisses in their ears, a strange thought begins to creep into the minds of the people in that room. It is an irrational thought, a thought that belongs in ghost stories, not in a science facility. The static sounds rhythmic. It's not the random chaos of burning hydrogen. It almost sounds like a pattern or a breath. The blind spot is huge. It is millions of kilometers of empty space hidden behind the fire. It is plenty of room for something to hide, plenty of room for something to change. We assume that when the planets align again, when Mars pops out from behind the sun, everything will be exactly as we left it. We assume the rovers will wake up. We assume the red dust will be the same red dust. But we are blind, and in the dark we are vulnerable. The engineers stare at the blank screens, and for the first time they are not just impatient, they are afraid. They are realizing that the scary part is not that the machines have stopped talking to us. The scary part is wondering, is something else talking to them? The sun continues to burn, masking the secrets of the dark with its blinding light. The wait continues. To understand why the disappearance of 3i Atlas sent a shiver down the spine of the entire scientific community, we must rewind the clock. We need to go back to the weeks immediately preceding the event, back to when the object was still just a bright spark on our long-range sensors cruising through the silent void between the planets. At that moment it was just a rock or so, we thought. It was a catalogue number, a set of coordinates, a routine homework assignment for the junior astronomers at the Pan-STARRS observatory. But as the object crossed the orbit of Mars and began its dive toward the inner solar system, the data began to scream that something was wrong. To appreciate the impossibility of what happened next, you first need a very simple understanding of how a comet works. In the vast, cold library of the universe, comets are the dusty, dirty snowballs. They are remnants from the dawn of creation, frozen lumps of rock dust and ice. When these frozen wanderers get close to a star, the heat wakes them up. The ice on their surface does not melt into water, it sublimates. This means it turns instantly from a solid block of ice into a gas. This gas bursts outward, carrying dust with it, creating a fuzzy envelope around the nucleus called a coma. Then comes the tail. This is the signature of a comet, its white flag waving in the cosmic wind. The physics of a comet tail are supposed to be as predictable as gravity itself. The sun is not just a light bulb, it is a massive engine pumping out a constant stream of charged particles and intense light. We call this the solar wind and radiation pressure. Think of the sun as a giant high-powered fan blowing outward in all directions. When the comet releases its gas and dust, that wind from the sun pushes against it. Therefore, by every law of nature we have ever observed, a comet's tail must point away from the sun. It does not matter which direction the comet is travelling. If the comet is moving towards the sun, the tail trails behind it. If the comet is moving away from the sun, the tail flies ahead of it, pushed outward by the solar wind. It is like a flag flying from a ship. The wind determines the direction of the fabric, not the destination of the boat. This is a rule. It is a fundamental constant of celestial mechanics. But 3i Atlas broke the rule. It began with a grainy image capture from the infrared telescope array in Hawaii. The object was approaching its perihelion, the point in its orbit closest to the star. The team on the night shift was expecting to see the familiar fan-shaped tail fanning out behind the object, pushed away by the fierce pressure of solar light. Instead, the image analyst thought the telescope was out of focus. He wiped his glasses, recalibrated the sensor, and took another exposure. The result was the same. On the monitor's 3i Atlas did not look like a comet being pushed by the wind. It looked like a dart moving against the wind. The stream of gas and particles the tail was not flowing away from the sun. It was pointing directly toward it. The initial report was logged as a sensor artifact, a polite way of saying a computer glitch. But as observatories in Chile and the Canary Islands locked onto the coordinates, the glitch refused to go away. The data was consistent. The object was ejecting mass, but that mass was forming a tight focused jet pointing straight at the star it was orbiting. The physics simulation models crashed as trying to predict its path. If this were a natural comet, the solar wind should be blowing that dust back. For a tail to point toward the sun, the particles would have to be incredibly heavy enough to ignore the pressure of sunlight, or, and this was the whisper that started in the break rooms, they were being ejected with immense force. Imagine you are standing in a hurricane. The wind is blowing hard against your face. You hold out a handful of flour and drop it. Naturally, the flour should blow back into your face. But imagine if you dropped the flour and it shot forward, cutting through the wind, flying straight into the storm. That would not be gravity. That would not be wind. That would be a bullet. That was what 3i Atlas was doing. It was shooting its exhaust into the solar wind. The confusion in the scientific community was palpable. Papers were drafted and discarded within hours. Some theorists tried to argue that the object was spinning so fast that it was flinging heavy metals toward the sun, creating an optical illusion. Others suggested it was a magnetic anomaly, that the object was made of iron and was interacting with the magnetic field of the sun in a way we'd never seen before. They used terms like magnetohydrodynamic drag to make it sound like a natural event. They filled whiteboards with equations trying to force the square peg of 3i Atlas into the round hole of natural history. But the motion of the object told a different story. Because of this anti-tail, this sunward jet, the object was not moving like a rock falling under gravity. It was accelerating. In orbital mechanics, everything is a trade-off between speed and gravity. If you are just a dead rock, you follow a curve defined by Isaac Newton 300 years ago. You speed up as you get close to a massive body and you slow down as you fly away. It is a perfect silent dance. But 3i Atlas was offbeat. It was moving slightly faster than gravity could explain. The anomalous acceleration was tiny, mere millimeters per second squared, but over the vast distances of space it was unmistakable. This is where the conversation shifted from astronomy to something more unsettling. When a rocket ship wants to slow down or change its orbit, it fires an engine. If you want to fight the pull of gravity, or if you want to brake against your current velocity, you shoot gas in the direction of your travel. The scientists looked at the screen, and then they looked at each other. The object was firing a jet toward the sun. The sun was the source of the gravity pulling it in. By shooting a jet toward the gravity well, the object was effectively pushing back. It looked like braking thrusters. For weeks, the debate raged behind closed doors. The comet hypothesis was falling apart. A natural comet outgassing venting steam from heated ice tumbles randomly. Events from wherever the sun hits the surface. It spins and wobbles like a deflating balloon. 3i Atlas was not tumbling. The light curve data showed it was perfectly stable. It was holding its attitude. The jet remained fixed, pointing precisely at the solar core, adjusting its angle slightly as it moved, maintaining that impossible vector. Nature is chaotic. Nature is messy. Nature does not draw straight lines, and it certainly does not maintain a stabilized firing solution against the solar wind. This behavior implied a center of gravity that was engineered, not accidental. It implied a structure that was balanced. The terrifying beauty of the anomaly was its silence. There was no radio signal. We pointed the largest radio dishes on Earth at it, the Greenbank telescope, the arrays in Australia, listening for a beep, a hum, a sequence of prime numbers. We heard nothing but the static hiss of the universe. It was a ghost ship running on automatic pilot, performing a maneuver that required a level of physics we could describe but could not actually explain. As the object drew closer to the point where it would eventually vanish, the spectral analysis came back. This was the final nail in the coffin of the natural rock theory. Comets are made of water, ammonia, methane, and carbon dioxide. We know the spectral fingerprint of these elements perfectly. When we looked at the light reflecting off the tail of 3I Atlas, the spectrometer did not find water. It did not find dust. The readings were flat. The material being ejected was almost pure plasma ionized gas with a heat signature that was far too high for simple sublimation. Ice turns to gas at 0 degrees Celsius. This material was thousands of degrees hot, yet the core of the object remained cold. How can a cold rock produce a jet of plasma hot enough to melt steel pointing directly into the solar wind without melting itself? The answer is that a rock cannot do that. A machine can. The anomalies of 3I Atlas forced us to confront a paradox that we were not ready for. If it looks like a duck, swims like a duck, and quacks like a duck, it is a duck. But if it looks like a rock, moves like a rocket, and stabilizes itself like a gyroscope, we are terrified to call it what it is. We stuck to the word anomaly because the alternative was too big to handle. We were watching something perform a controlled orbital insertion. We were watching a visitor pump the brakes. The tail pointing toward the sun was not a freak of nature. It was a deceleration burn, and the reason it was slowing down was the most chilling realization of all. You only slow down if you intend to stop or if you intend to deploy something. Nature throws dice. 3I Atlas was playing chess, and as it pivoted for its final maneuver just days before the signal cut out, humanity sat in the observation room staring at the screens, realizing that for the first time in history, the stars were not just watching us, they were acting upon us. The universe was no longer a lonely place, and that was infinitely more frightening than the silence had ever been. The anticipation leading up to October 3rd was unlike anything the astronomical community had experienced in decades. For weeks, the eyes of the world had been fixed on the trajectory of 3I Atlas, tracing its lonely path through the darkness of the outer solar system. But as the object approached the red planet, the focus shifted from amateur telescopes on Earth to the sophisticated network of machines already orbiting Mars. This was supposed to be the moment of clarity, the day the blurry smudge of light would finally resolve into a tangible shape. Humanity has a significant presence around Mars. It is the busiest parking lot in the solar system outside of Earth itself. We had the Mars Reconnaissance Orbiter known as MRO, equipped with the high-rise camera, a lens so powerful it can spot a coffee table on the Martian surface from space. We had the European Space Agency's Trace Gas Orbiter, the United Arab Emirates' Hope Probe, and China's Tianwen-1 mission. It was a multinational paparazzi squad, all waiting for the celebrity to walk the red carpet. The geometry was perfect. 3I Atlas was scheduled to pass within roughly 12 million kilometers of Mars. In cosmic terms, this was a close shave. It was close enough for high-resolution imaging, close enough to determine composition, rotation, and surface features. The flyby occurred exactly on schedule. The math of the universe is rarely wrong, but the narrative that followed was messy, confusing, and deeply unsatisfying. At 14:00 Coordinated Universal Time, the data downlink began. The world's press agencies had their breaking news graphics ready. Live streams on YouTube and news networks were hosting panels of experts waiting to analyze the first close-ups, but the images never came, at least not immediately. The live feeds from NASA and ESA cut to holding screens or looped animations of the orbiters. The hosts filled the dead air with nervous chatter about signal latency and deep space bandwidth limitations. When the first image was finally released 4 hours later, the collective groan of the scientific community was audible. It was a grey, grainy square. In the centre sat a nebulous, pixelated blob that looked more like a thumbprint on a camera lens than a celestial body. The official caption described it as a cometary nucleus obscured by heavy outgassing. The official statement from the major space agencies was coordinated and blunt. They claimed that as 3I Atlas passed Mars, it released a sudden massive cloud of dust and gas, a coma that effectively blinded the cameras. They also cited a coincidental solar flare that caused telemetry degradation and packet loss right at the moment of closest approach. Essentially, they told the world bad timing, bad luck, and bad weather. But the internet does not believe in coincidences, and certainly not 3 of them happening at once. Almost immediately, the cracks in the official story began to show. Amateur radio astronomers who monitor the carrier waves of deep space probes noted something peculiar. The data transmission rates from the Mars orbiters had spiked significantly after the flyby. The MRO alone had transmitted terabytes of data back to the Deep Space Network in Australia. If the cameras had been blinded by dust and the sensors scrambled by a solar flare, what were they sending? Noise does not take up that much bandwidth. High-resolution uncompressed video files, however, do. By October the 5th, the rumours of the lost frames began to circulate. Whistleblowers are a staple of modern conspiracy culture, but the leaks coming out of the imaging labs felt different, more technical, more specific. On encrypted forums and dark web message boards, users claiming to be contractors for the data processing teams began to speak. They spoke of the raw feed. They claimed that the picture released to the public, the blurry grey blob, was indeed real, but it was taken hours after the flyby. The images taken during the closest approach, the so-called .0 frames, had been flagged, encrypted and removed from the public server queues. One particular leak, which cannot be verified, but has persisted in the digital underground, described a photo from the high-rise camera. The leaker claimed the object was not a jagged rock or a dusty snowball. They described it as albedo anomalies on a dark surface. In plain English, they saw lights, not the steady reflection of the sun, but geometric patterns of high reflectivity that seemed unnatural. Another rumour from a source allegedly close to the Chinese Tianwen team suggested that their radar data showed the object was spinning, but the axis of rotation was shifting in a way that defied simple gravity. A tumbling rock tumbles chaotically. This object was correcting itself. The discrepancy between what the public saw and what the logic of the situation dictated created a thick fog of mystery. We know the capabilities of our technology. We have photographed asteroids much smaller and much further away with crystal clarity. The idea that every single camera from 3 different nations all failed to get a clear shot at the same time is statistically impossible. The outgassing explanation also failed to hold up to scrutiny from independent astronomers. If 3i Atlas had released a cloud of gas thick enough to block a camera view, that cloud would have expanded. It would have caught the sunlight. It would have created a massive glowing tail visible to telescopes on Earth. But Earth-based observers saw no sudden brightening. The object remained a dim, steady point of light. The cloud existed only in the press releases, not in the sky. Then came the issue of the timeline. Between the moment 3i Atlas entered the high-sensitivity zone of the Mars sensors and the moment it left, there is a gap in the public timestamps. 19 minutes are missing from the telemetry logs of the MRO, 19 minutes where the probe was perfectly positioned. In the metadata of the files that were released, digital forensic experts found traces of heavy editing timestamps that didn't align background star fields that had been cloned to cover gaps and noise profiles that looked artificial. This was not just a case of a bad photo, it looked like a redaction. The psychological effect of the Mars encounter was profound. Before October 3rd, 3i Atlas was a scientific curiosity. After October 3rd, it became a source of anxiety. The silence of the space agencies did not calm the public, it fueled the fire. By refusing to show the clear images that surely existed, the authorities implicitly confirmed that there was something to hide. They turned a rock into a ghost. As 3i Atlas left the orbit of Mars and continued its keen dark rush toward the inner solar system, the mood on Earth shifted. We were no longer waiting for a visitor, we were waiting for a revelation. The object had been scanned by our best machines, and the machines had blinked, or rather the people controlling them had forced them to blink. The question was no longer what is it? The question had become, why are they afraid to show us? The Mars encounter proved that the barrier to understanding was not the distance of space, but the filter of information. And as the object crossed the distance between Mars and Earth, that filter was about to be tested to its breaking point. The amateur astronomers on Earth, with their backyard telescopes and obsession with the truth, were now the only ones the public trusted. The official channels had gone dark, and in that darkness, imagination and fear began to take root. To understand what this visitor really is, we cannot use a hammer and chisel. We could not land on it, scrape a sample, or bring a piece back to a laboratory on Earth. Instead, we had to touch it with our eyes. We had to rely on light. When sunlight hits an object in space, that object reflects the light back to us. But it does not just reflect a picture, it reflects a code. Every element in the universe absorbs and reflects light in a very specific way, creating a unique barcode. By reading this barcode, astronomers can tell you exactly what a rock is made of, even if it is millions of miles away. This is the chemical fingerprint, and in the case of this interstellar object, the fingerprint was unlike anything we have ever seen in our history of staring at the stars. The first thing the light told us was about the surface. It was dark with a distinct reddish hue. In our own solar system, red usually means one specific thing: organic materials. When simple carbon-based molecules interact with cosmic radiation over millions of years, they bake into a hard red crust. We call these tholins. Finding this on the surface was interesting but not revolutionary. We see this on objects in the Kuiper belt at the edge of our own neighbourhood. It told us the object had been travelling for a long time exposed to the harsh radiation of deep space. However, what was happening beneath that red crust was the real mystery. As the object tumbled past the sun, the heat began to affect it. Usually when a space rock gets warm, it releases what it is made of in the form of gas. This is where things became strange. Telescopes trained on the object began to look for the signatures of metals. In almost every asteroid we have ever studied, iron and nickel are best friends. They are almost always found together. If you find a metallic asteroid, you find iron and you find nickel mixed in with it. It is a standard recipe of the cosmos dating back to the way stars create heavy elements. But this visitor broke the rule. We detected the clear signature of atomic nickel in the gas surrounding the object. It was there, present and obvious. But where was the iron? The ratio was completely wrong. The data suggested a surface that was rich in nickel, but surprisingly poor in iron. This is incredibly rare. It implies that the object did not form in the chaotic mix of a standard dust cloud like our asteroids did. Instead, it suggests that the materials were separated. Perhaps this object was once part of a much larger planet that had a molten core, where heavy metals settled and separated, and this rock is a shard from that destroyed world. Or perhaps it was created in a region of space where the dust itself had a completely different chemical composition than our solar system. The presence of atomic nickel without its partner iron was the first clue that we were dealing with a foreigner. Then came the second and perhaps more significant chemical shock, the gas. When a comet comes near the sun, it acts like a dirty snowball. The ice melts and turns into gas, creating a beautiful tail. That gas is almost always water vapor. Water is the most common solvent in the universe and our comets are full of it. We expected this visitor to release water vapor as well. We waited for the hydrogen and oxygen signals, but they never came. The Spitzer Space Telescope, one of our most sensitive instruments, looked deep into the infrared spectrum to find the heat signature of water gas, and it found nothing. Instead, the chemical fingerprint revealed something else. The object was not releasing water. It was releasing carbon dioxide and carbon monoxide. The calculations were staggering. For every single molecule of water that might have been there, though, we barely saw any. There were 8 molecules of carbon dioxide, a ratio of 8 to 1. This number is crucial. It is the smoking gun of the object's origin. To understand why, we have to look at how things freeze. Water freezes at 0 degrees Celsius. It is relatively easy to keep water as ice in space, but carbon dioxide is much harder to keep frozen. It turns into gas at much lower temperatures. For a rock to form with that much carbon dioxide ice locked inside it, and to keep that ice for millions of years, it must have been born in an environment of extreme bone-crushing cold. This tells us about the factory that built this object. Our solar system has a snow line a distance from the sun where it is cold enough for water to freeze. Earth is inside that line, which is why we have liquid water and Jupiter is outside of it. But the factory that made this object had a snow line that was much, much further out. The chemical evidence suggests this object was not formed near a star. If it had been born close to a hot sun, the carbon dioxide would have boiled away billions of years ago. The fact that it is packed so full of this volatile gas tells us it condensed in the darkest, coldest outer edges of a planetary system, or perhaps in a dark cloud of gas that had not yet even formed a star. Imagine a place far from any sun where the temperature hovers just a few degrees above absolute zero. In this deep freeze, carbon gases turn into solid ice. Dust grains in this environment get coated not with water but with frozen carbon clouds. This object collected that material layer by layer in the dark. It is a pristine sample of a frozen world we can scarcely imagine. The 8-to-1 ratio serves as a ticket from a different climate. It is like finding a creature with thick white fur walking through a tropical jungle. You know immediately that it evolved in the Arctic. Similarly, the chemical makeup of this object screams deep cold. It implies that the system it came from might have been a red dwarf system, a small cool star or a binary star system, where the gravitational chaos pushed materials far out into the freezing void. Furthermore, this chemical profile challenges our definition of comet versus asteroid. In our system, comets are water ice, asteroids are rock and metal. This visitor is a hybrid that defies our classification. It has the dark red organic surface of an asteroid, the nickel composition of a processed metal object, but the gaseous heart of a carbon-rich comet. It is a chimera. This unusual combination supports the idea of a planetary shard. If an Earth-like planet, or perhaps a super-Earth rich in carbon, was torn apart by the gravity of a dying star, the resulting debris would look exactly like this. You would have pieces of the core explaining the metals mixed with the frozen atmosphere, explaining the carbon dioxide. So what does this chemical fingerprint tell us in the end? It tells us that the recipe for making worlds is not the same everywhere. In our kitchen, the solar system, we use water iron and silicate rock. But in the factory that built this visitor, the cooks used different ingredients. They used heavy carbon ice, separated metals, and extreme cold. This object is a time capsule from a place that is very cold, very far away, and likely very ancient. It carried its frozen heart across light years of empty space, holding on to that carbon dioxide like a treasure, only to release it for a few brief weeks as it passed our sun. It allowed us to sniff the air of an alien world without ever leaving our own planet. It proved that the diversity of material in the galaxy is far greater than we had assumed, and that out there in the dark there are worlds built of ice and gas that would seem like magic to us. For decades, astronomers have stared into the black ocean of space waiting for a phone call. We listen to the static, hoping to hear a voice, a pattern, or even just a whisper that would tell us we are not alone. In all of history, we only ever heard one thing that truly scared us. It happened on a summer night in 1977. It was called the WOW signal. To understand the terrifying importance of Object 3I Atlas, we must look back at that moment. It was detected by the Big Ear radio telescope in Ohio. For 72 seconds, a strong, loud, and continuous radio wave blasted the Earth. It came from the direction of the constellation Sagittarius. It was 30 times stronger than the background noise of the universe. When the astronomer Jerry Amon saw the data on the computer printout, he was so shocked that he circled it with a red pen and wrote the word WOW in the margin. That signal was broadcast at 1420 MHz. This is a very specific frequency. It is the frequency of hydrogen, the most common element in the universe. Many scientists believe that if intelligent aliens wanted to say hello, they would use this frequency because it is a universal language. It was perfect, it was loud, it was deliberate. But then it vanished. For 48 years, we pointed our biggest ears back at that spot in the sky. We listened until our computers overheated. We heard nothing but silence. The signal was gone. Many people started to believe it was a mistake, perhaps a secret satellite or a reflection from space junk. The mystery became a cold case. Until today, until 3I Atlas. As the team analysed the backward trajectory of 3I Atlas, tracing its path backward in time to see where it came from, a chilling realisation settled over the control room. The computer models drew a long, curved line, extending out of our solar system past the orbit of Mars, past the asteroid belt, and deep into interstellar space. The line pointed directly at the constellation Sagittarius. This was the first shock. The object 3I Atlas was travelling from the exact same region of the sky where the WOW signal originated. But space is vast. Two things coming from the same general direction could just be a coincidence. It is like two cars driving on the same highway. It does not mean they know each other. We needed more proof. Then came the timing analysis. The WOW signal hit Earth in the 1977. 3I Atlas arrived near Earth in 2025. The difference is exactly 48 years. This number is not random. In the orbital mechanics of deep space objects, loops and return periods are critical. If a probe was sent to ping a location, and then a physical ship was sent to investigate the response, the travel time would be calculated precisely. Professor Avi Loeb has often hypothesized about this scenario. He suggests that we should not look for massive spaceships like in the movies. Instead, we should look for space trash, or discarded technology from other civilizations. He compares it to finding a plastic bottle on a beach. The bottle is not the civilization, but it proves the civilization exists. But the most disturbing piece of data was not the timing, it was the angle. When the navigation team overlaid the path of the original WOW signal with the approach vector of 3I Atlas, they found a discrepancy. They were not perfectly aligned. There was a difference of exactly 9 degrees. At first glance, a 9-degree difference seems like a miss. It looks like an error. But in the mathematics of space travel, a 9-degree inclination shift is incredibly difficult to achieve naturally. Comets and asteroids follow the gravity of the sun and stars. They fall down gravity wells like marbles rolling into a hole. To change an angle by 9 degrees requires energy. It requires a push. In physics, we call this a non-gravitational acceleration. If 3I Atlas were just a frozen rock, it should have followed the gravity of Jupiter and the Sun perfectly. But the data showed that somewhere in the deep dark about 20 years ago, 3I Atlas changed its mind. It shifted its path by 9 degrees. Why? The simulation showed the answer, and it made the hair on our arm stand up. If 3i Atlas had stayed on its original course without that 9-degree shift, it would have missed Earth by millions of kilometers. It would have passed by unnoticed, just another rock in the dark. But with that 9-degree shift, that adjustment put it on a perfect collision course with the orbital plane of Earth. It was not drifting, it was aiming. This creates a connection that is impossible to ignore. The theory suggests a cause and effect relationship. Imagine a scenario. In 1977, an alien system sends out a scanner beam. That was the WOW signal. It sweeps across the galaxy like a lighthouse. It hits Earth. It detects radio waves, television broadcasts, and radar pings the noise of a young technological civilization. The scanner reports back to the main network life found here. The network then dispatches a physical probe to go and look closer. But space is big and travel is slow. It takes 48 years for the physical drone to arrive at the coordinates found by the scanner. This explains the silence. They did not need to keep broadcasting the WOW signal. They had already found us. They stopped talking and started traveling. The object 3i Atlas is not a comet. The tail of gas we see might not be melting ice. It could be the exhaust of a maneuvering thruster or waste heat from an engine trying to slow down. The reddish colour of the surface matches the description of aged organic material, or perhaps the burnt shielding of a vessel that has travelled between stars for centuries. The 9-degree shift was the course correction. It was the moment the probe adjusted its sails to enter our solar system. We are no longer looking at a piece of ice, we are looking at a visitor. The implications are staggering. If this hypothesis is true, 3i Atlas is an ancient machine. It is a sentient probe. It has been travelling through the void, sleeping, waiting until it got close enough to its target. And now it is waking up. The sensors on the 3i Atlas are likely coming online. It is tasting the solar wind. It is listening to our radio leaks. It is watching our cities glow at night. The coincidence of the 48-year gap and the 9-degree specific adjustment removes the comfort of luck. Nature creates chaos. Intelligence creates order. The path of 3i Atlas is too orderly. As the object draws closer, the question changes. We are no longer asking, what is it? We are now asking, what does it want? Is it a scientist here to study us like bacteria in a petri dish? Is it a judge here to decide if we are a threat, or is it something else entirely, a gentle greeting from a lonely neighbour? The WOW signal was the knock on the door. 3i Atlas is the guest stepping inside the house, and we are standing in the hallway unsure if we should welcome them or lock the door. But it is too late to lock the door. The guest is already here. The silence of the last 48 years was not empty. It was the deep breath before the plunge. We thought the WOW signal was a one-time event, a ghost in the machine. We were wrong. It was the start of a conversation. And 3i Atlas is the second sentence. To understand this object, we must first stop thinking in terms of human time. A human life is measured in decades. The history of civilization is measured in centuries. Even the history of our own planet, the Earth, is measured in a specific timeline that we have grown comfortable with. But 3i Atlas demands that we break that scale. The data returned from the interceptor probes has confirmed something that initially seemed like a glitch in the mathematics. By analysing the radioactive decay of the isotopes trapped deep within the ice of the comet, and by reading the faint chemical signature of its dust, scientists have determined its age. 3 Atlas is 10 billion years old. Let that number sink in. The solar system, our sun, the Earth, Jupiter, and everything we have ever known is roughly 4.6 billion years old. This means that the visitor currently moving through our neighbourhood is more than twice the age of the ground you are standing on. It is more than twice the age of the sun that warms your face. When 3i Atlas was born, our solar system did not exist. There was no Earth, there was no sun, there was only a thin cold cloud of gas and dust floating in a dark corner of the galaxy waiting for a spark that wouldn't come for another 5 billion years. This comet is not just a visitor from another place, it is a visitor from another time. The universe of the beginning. Imagine the universe as it was 10 billion years ago. It was a very different place than the one we see in our telescopes tonight. It was a younger, wilder, and more violent universe. In astronomy, we often talk about metals. To a scientist, this doesn't just mean iron or copper. It refers to anything heavier than hydrogen and helium. Today, our universe is rich in these materials. We have carbon, oxygen, nitrogen, and iron. These are the things that make planets, rocks, and human bodies. But these heavy elements are cooked inside the hearts of dying stars. It takes generations of stars living and dying to fill the universe with these building blocks. 10 billion years ago, the universe was metal poor. It was still clean. The stars that existed back then were ancient massive beasts burning blue and hot, composed almost entirely of primal hydrogen and helium. The Atlas was born in this era. It was formed in a protoplanetary disk, a swirling ring of dust and gas around one of these ancient stars. But because the universe was so young, the chemistry of 3I Atlas is strange to us. It lacks the heavy chemical complexity of a comet born in our own system. It is made of simpler stuff. It is a pristine sample of the early days, a frozen time capsule preserving the recipe of the galaxy when it was still in its infancy, the Great Ejection. So how did it end up here? We believe that shortly after it formed, 3I Atlas was a victim of gravity. In that ancient solar system 10 billion years ago, there were likely giant planets, massive gas giants like our Jupiter or Saturn, fighting for space. In their chaotic dance of a young star system, gravity is a harsh master. One day, billions of years before Earth existed, 3I Atlas swung too close to one of these giant planets. The massive gravity of the planet grabbed the small comet and used it like a slingshot. It didn't crash. Instead, it was accelerated. It was kicked with tremendous force, faster and faster, until it reached escape velocity. It broke free from the grip of its parent star. It left its home. It crossed the boundary of its solar system and entered the dark, cold void, the longest journey. This is where the true story of 3I Atlas begins. This is the story of the interstellar medium, the space between the stars. For us, a long trip might be a flight across the ocean. For a spacecraft like Voyager, a long trip is 40 years to reach the edge of our system. For 3I Atlas, the trip has been an eternity. For 10 billion years, it has drifted. Try to visualize the absolute isolation. In the space between stars, there is almost nothing. It is a near-perfect vacuum. There is no wind to erode the surface. There is no warmth to melt the ice. There is only silence and darkness. The temperature sits just a few degrees above absolute zero, the coldest possible temperature in physics. At this temperature, atoms hardly move, chemistry stops, time in a way freezes. While this object was drifting through the dark, the Milky Way galaxy was rotating. Our galaxy spins like a giant pinwheel. It takes about 230 million years for the galaxy to spin once. 3I Atlas has been drifting for so long that it has circled the center of the galaxy more than 40 times. It is a traveler that has seen the entire galaxy rotate again and again, a witness to history. Consider what has happened while this lonely rock was floating in the void, doing absolutely nothing but moving forward. While 3I Atlas was in its second billion year of travel, our sun finally ignited. A cloud of gas collapsed and our light was turned on. The comet didn't know. It was light years away in the dark. While it continued to drift, the Earth cooled down. Oceans formed. The first simple bacteria began to swim in our primal seas. 3I Atlas was still billions of miles away, frozen in silence. Life on Earth exploded. Fish crawled onto land, forests grew, the dinosaurs rose to power, ruled the planet for millions of years and were wiped out by an asteroid. Throughout all of that drama, all of that noise and death and life, 3I Atlas was simply floating, gliding. Great civilizations rose and fell, the pyramids were built, wars were fought, the internet was invented, and only now, by pure chance, has its path intersected with ours. The scars of the void. However, the journey has not been entirely without consequence. While space is empty, it is not safe. For 10 billion years, 3I Atlas has been bombarded by cosmic rays. These are high-energy particles, tiny subatomic bullets that fly through the universe at nearly the speed of light. When you travel for 10 billion years, you get hit by a lot of them. This bombardment has altered the skin of the comet. The surface has been baked by radiation, turning the outer layer into a dark, crusty organic material. It is like a dark shell protecting the pristine ice inside. This is why the object appeared so dark to our telescopes at first. It is sunburned by the radiation of the galaxy itself. The fact that it has survived is a miracle of statistics. It has dodged other stars. It has avoided getting sucked into black holes. It has avoided smashing into other dust clouds. It has threaded the needle through the galaxy for an amount of time that the human brain struggles to comprehend. The arrival. Now it enters our solar system. To 3I Atlas, our sun is just another bright light that it is passing by. It feels the warmth of a star for the first time in eons. The ice deep inside, which has been frozen since the dawn of the galaxy, is beginning to wake up. It is sublimating, turning from solid directly into gas, creating the faint tail we see today. That gas is the breath of the ancient universe. When our senses taste that gas, we are tasting the flavor of the cosmos as it was 10 billion years ago. It is here, but not for long. It is moving too fast to be captured by the sun's gravity. It is not staying. It is just passing through. It is a traveler that has been walking for 10 billion years, stepping into our house for a brief moment and then walking out the back door back into the night. The solitude of eternity. When you look up at the night sky and imagine where this object is, do not just think of it as a rock. Think of it as a fragment of memory. It reminds us that we are the new kids on the block. Our solar system is young. Our history is a blink of an eye. 3i Atlas represents the deep, crushing, beautiful timeline of the universe. It carries with it a profound loneliness, a solitude that has lasted longer than the existence of our planet. It has travelled through the silence for 10 billion years to reach us, and in a few months it will be gone again, returning to the void, continuing its silent dark journey for perhaps another 10 billion years long after the Earth is gone. It is the ultimate witness. It watches the stars die. Right now, at this very second, the comet has vanished from our direct sight. It has slipped behind the massive golden curtain of the Sun, entering a region of space that astronomers often call the zone of death. From our perspective on Earth, there is only silence and a blinding glare that our telescopes cannot penetrate without special filters. But if we could transport ourselves to that location, hovering safely alongside the traveller, we would witness a scene of violence and majesty that defies the human imagination. This is the solar crucible, and the physics at play here are not just equations on a chalkboard. They are the raw destructive forces that govern the universe. The first thing one would notice is the environment itself. The comet is no longer flying through the cold, empty vacuum of deep space. It is now swimming through the Sun's outer atmosphere known as the corona. This is a ghostly, superheated halo of plasma that extends millions of kilometers into space. The temperature here is a paradox. While the surface of the Sun is incredibly hot, the corona is vastly hotter, reaching temperatures of over 1 million degrees. The comet is plunging into a bath of fire that is hotter than the center of a nuclear explosion. In this inferno, the physical state of the comet changes instantly and violently. For millions of years, this object was a frozen statue, a mountain of ice and dark dust sleeping in the deep freeze of the outer solar system. Now it is being subjected to a thermal shock that is almost impossible to quantify. The heat does not merely melt the ice into water. There is no liquid here. The pressure is too low and the heat is too intense. Instead, the ice undergoes a process called sublimation. It transforms directly from a solid rock of frozen gas into a violently expanding vapor in the blink of an eye. Imagine the surface of the comet not as a solid ground, but as a landscape of thousands of exploding geysers. Every square inch of the comet that faces the Sun is erupting. The frozen carbon dioxide, carbon monoxide, and water ice are blasting outward with the force of jet engines. This is not a gentle evaporation, it is a continuous explosion. These jets of gas are moving at speeds of hundreds of meters per second, carrying with them tons of dust and rock. The comet is literally peeling itself apart, shedding its skin in layers to try and cool its burning core. Beneath this chaotic surface, a battle of structural integrity is taking place. We often think of comets as solid rocks, but many are actually what scientists call rubble piles. They are loose collections of boulders and gravel held together only by their own weak gravity and the glue of frozen ice. As the heat penetrates deep into the nucleus, that ice glue turns to gas. It creates massive pockets of pressure inside the mountain. If this pressure finds a weak spot, it can blow the comet into fragments, shattering it like a grenade before it even emerges from behind the Sun. However, heat is not the only enemy here. There is also the invisible crushing hand of gravity. The Sun contains 99% of all the mass in our solar system. At this close distance, its gravitational pull is titanic, but the danger comes from how this gravity changes over the length of the comet. The front of the comet, the nose pointing toward the Sun, is being pulled significantly harder than the back of the comet. This is known as tidal force. It is a stretching effect similar to how the Moon pulls the oceans on Earth, but amplified by a factor of billions. This tidal force wants to pull the comet into a long, thin line of debris. It is a tug of war between the comet's own gravity trying to hold itself together and the Sun's gravity trying to rip it apart. If the comet passes a specific invisible boundary, the Sun will win and the object will crumble into a stream of dust, never to be seen as a whole object again. While the nucleus fights for survival, the tail of the comet is suffering its own violent assault. The Sun is not just a light bulb, it acts like a machine gun firing a constant stream of charged particles known as the solar wind. At this range, the solar wind is a hurricane of protons and electrons slamming into the gas cloud surrounding the comet. This wind hits the comet with such force that it can completely strip away the tail, tearing the gas free from the nucleus. This is called a disconnection event. It looks as if the comet has been decapitated, its beautiful flowing hair cut off by a blade of magnetic energy. Adding to this chaos is the velocity. The speed of the object is currently staggering. It is moving at hundreds of kilometers every single second. To put that in perspective, at this speed, you could travel around the entire Earth in just a few minutes. This immense speed creates a kinetic energy that is hard to comprehend. The comet is skimming the surface of the star, screaming through the solar atmosphere. The friction from the tenuous gases of the corona is small, but at these speeds, even a few atoms striking the comet can cause drag and heating, adding to the misery of the traveller. We must also consider the magnetic violence. The Sun is a churning ball of magnetic fields that twist and snap. If the comet flies through a magnetic loop or a solar flare, it will be hit by radiation that includes X-rays and ultraviolet light so intense it would sterilize a planet. These waves of radiation pummel the dust grains, breaking down their chemical bonds, altering the very makeup of the material that has existed since the dawn of the solar system. Yet amidst this hellscape of gravity, magnetic storms and searing heat, there is a chance for survival. The sublimation, the very thing that is destroying the comet, also acts as a shield. The massive cloud of gas and dust exploding off the surface creates a temporary atmosphere, a cocoon that blocks some of the worst heat from reaching the deep frozen heart of the nucleus. It is a sacrificial defense. The comet burns its outer layers to save its soul. Right now, the battle is at its peak. The comet is at the point of closest approach, known as perihelion. This is the moment of maximum danger. The gravitational stretch is at its strongest. The heat is at its maximum. The pressure inside the core is critical. It is a silent war between the binding energy of a dirty snowball and the fusion power of a star. On Earth, the coronagraph images from our satellites are updating slowly. We are waiting for the pixels to appear on the other side of the solar disk. We are waiting to see if a bright, solid point of light emerges triumphant and scarred, or if we will see only a ghostly smear of expanding dust, the tombstone of a traveller that flew too close to the flame. The physics have done their work, now we simply wait for the verdict of nature. The waiting is always the hardest part of any scientific endeavour, but the silence of this particular December feels heavier than usual. As the Earth continues its orbit, positioning itself for the optimal viewing angle, the global astronomical community stands on the edge of a precipice. We are past the stage of wild guessing and initial discovery. Now we are entering the phase of verification. The object, having swung around the Sun, is emerging from the solar glare. This is the moment the December promise comes due, the moment the data will either crush our wildest dreams or change human history forever. When the object first dipped below the plane of the solar system and vanished into the Sun's brilliance, we were left with nothing but mathematical models and fierce debates. Now, as it climbs back out into the dark, cold vacuum, we are looking for three distinct possibilities. The suspense lies in the fact that any one of them is plausible, yet they lead to entirely different futures for humanity. The first scenario, and the one favoured by the conservative skeptics, is total fragmentation. We call this the crumbling. The object passed perihelion, its closest point to the Sun, at a distance where the heat was intense, likely reaching temperatures of over 1000 degrees Celsius. If this visitor is simply a dirty snowball, a loosely packed comet, or a fragile asteroid, the thermal shock should have been fatal. In this scenario, when we point our lenses at the coordinates, we will not see a single bright point of light. Instead, we will see a hazy cloud of dust and gravel, a ghost of what used to be. The gravitational forces of the Sun would have torn it apart, scattering its remains into a long, meaningless stream of debris. If we see this, the story ends. It was just a rock and the universe remains a lonely, quiet place. The second scenario is the natural survival. In this version of events, the object emerges intact. It has survived the fire. This would tell us that the object possesses incredible structural integrity. It would imply that it is made of something far denser than ice or porous stone, perhaps a solid iron-nickel core, or a rare metallic composition we rarely see in our own asteroid belt. However, in this scenario, the object behaves exactly as Isaac Newton predicted 300 years ago. It slows down as it moves away from the Sun, following a perfect predictable hyperbola governed solely by gravity. It remains a dumb rock, just a very tough one. It offers no signals, no course corrections and no anomalies. It is a visitor, but an indifferent one. The third scenario is the one that keeps astronomers awake at night. It is the scenario of abnormal acceleration. This is what we saw with the interstellar object Oumuamua years ago, but we are looking for something more definitive this time. We are watching to see if the object moves differently than gravity alone would dictate. If it pushes away from the Sun faster than it should, or if it makes a lateral shift in its trajectory without venting gas, we are left with only one uncomfortable conclusion: something is pushing it. A natural rock cannot steer itself. If we measure a change in velocity, even a tiny one, perhaps just a few millimeters per second squared, that cannot be explained by outgassing, it implies propulsion. It implies a solar sail catching the light or an engine we cannot see. This is the December promise that the dreamers are hoping for proof that the object is not just falling but travelling. To catch this moment, the Earth has become a single giant eye. The preparation for this re-emergence has been unprecedented. It is a coordinated global effort that ignores borders and politics. In the high, dry Atacama Desert of Chile, the giant optical telescopes are calibrating their mirrors. The operators there are preparing for first light on the returning target. They are not just taking pictures, they are preparing spectrographs. These instruments break light down into a rainbow of colours to reveal chemical composition. They are desperate to know what the surface is made of. If the spectrum shows signs of refined metals, aluminum, titanium, or artificial alloys rather than just silicates and carbon, the debate will be over instantly. Meanwhile, in the classic observatories atop the dormant volcanoes of Hawaii, infrared telescopes are cooling down their sensors. They need to be colder than the space they are looking at. They are looking for heat. As the object moves away from the sun, it will re-radiate the heat it absorbed. By measuring how quickly it cools down, we can determine its density and surface texture. A hollow shell cools down differently than a solid rock. A polished metal surface reflects heat differently than a dusty crater. High above the atmosphere, the space telescopes have been pre-programmed with the precise coordinates. Unaffected by clouds or the shimmer of the Earth's atmosphere, they will provide the clearest look. They are hunting for the shape. Is it a cigar? A disc? A sphere? Or is it something jagged and irregular? The resolution might not be enough to see windows or antennas, but it will be enough to define the geometry. Nature rarely makes perfect geometric shapes. If we see a perfect rectangle or a flat disc, the implication of artificiality becomes almost undeniable. Perhaps the most intense preparation is happening at the radio observatories. Huge dish arrays in Australia, South Africa, and the Americas are tuning their receivers to silence the background noise of the cosmos. They are listening for a techno-signature. They are not just listening for a message, they are listening for the leakage of technology. This could be a radar ping used by the object to navigate a communication beam sent back to a home star, or simply the electromagnetic hum of an operating engine. The frequencies are scanned systematically, billions of channels at a time. The technicians are looking for a signal that is narrow and steady, something that nature, which is usually messy and broadband, cannot produce. We must also consider the synthesis of the clues we have gathered so far. We are combining the trajectory data from months ago with the new incoming data. We are looking for consistency. Did the rotation period change? Before it went behind the sun, it was tumbling every 8 hours. If it emerges spinning every 20 hours, or if the tumbling has stopped and it is now stabilized, that is a sign of internal damping or active control. G tends to conserve angular momentum. Things don't just stop spinning on their own without an external force. As this date approaches, the atmosphere in the control rooms is a mixture of caffeine-fueled exhaustion and electric anticipation. Every data packet is checked, double-checked and triple-checked. No one wants to be the person who announces a false alarm, but no one wants to miss the signal either. This is the summary of our position in December. We have the tools, we have the math, we have the eyes of the entire species turned upward. The clues are scattered across the spectrum in the light, the heat, the motion and the radio waves. We are about to collect them all and put the puzzle together. The December promise is not a guarantee of aliens. It is a promise of clarity. Whether it returns as a cloud of dust, a silent stone, or a speeding ship, we will finally know. The time for speculation is ending. The data is coming. And once that data arrives, we must move from the excitement of the hunt to the profound quiet work of understanding what it means for our place in the universe. We have spent a long time looking at the small, fast-moving shadow of 3i Atlas. We have analysed its strange path, its fading tail, and its lonely journey. But now it is time to pull back. Imagine for a moment that you are a camera zooming out from that single tumbling rock. You pull back past the orbit of Jupiter, past the icy ring of the Kuiper Belt, and past the invisible bubble of our sun's influence. As you keep moving backward, the sun becomes just another dot of light, blending into a vast river of silver spilled across the dark sky. Welcome to the City of Stars, welcome to the Milky Way. To understand the story of objects like 3i Atlas, or even the story of our own Earth, we must understand the massive structure that holds us all together. We often think of space as empty, but we actually live in a crowded, busy metropolis. The Milky Way is a barred spiral galaxy. If you could fly high above it and look down, it would look like a giant glowing pinwheel. It has a bright yellowish center that stretches out into a bar shape, and from the ends of that bar, magnificent arms of blue and white light spiral outward into the darkness. This city is so wide that even light, the fastest thing in the universe, takes about 100,000 years to travel from one side to the other. It contains somewhere between 100 billion and 400 billion stars. That number is so large it is hard to visualize. Think of it this way: for every grain of sand on every beach on Earth, there is a star in our galaxy, and nearly every one of those stars has its own family of planets. So where is our house in this city? We do not live in the downtown area. The center of the galaxy is a chaotic, crowded, and dangerous place filled with intense radiation and exploding stars. We also do not live in the remote countryside at the very edge of the disk. We live in the suburbs. Our solar system is located in a quiet neighborhood known as the Orion Arm. We are about 26,000 light-years away from the center. This is a very lucky location. It is often called the galactic habitable zone. It is not too hot, not too crowded, and stable enough for life to survive for billions of years without being wiped out by cosmic disasters. However, even our quiet suburb is dominated by what lies in the very center of the city. If you look toward the constellation of Sagittarius in the night sky, you are looking toward the heart of the galaxy. You cannot see it with your eyes because thick clouds of dust block the view, but radio telescopes can see right through the dust. Resting there in the absolute center is a monster. It is a supermassive black hole called Sagittarius A, pronounced Sagittarius A star. This object is the anchor of our galaxy. It is 4 million times heavier than our Sun, all crushed into a space smaller than the orbit of Mercury. Its gravity is terrifyingly strong. Stars near the center do not move in slow, lazy circles. They whip around this black hole at incredible speeds, like race cars on a tight track. While it sounds scary, our Sagittarius A is actually a quiet monster right now. It is not actively eating huge amounts of matter, but it sits there as the gravitational hub of our galactic city. But the most important thing to realize about the Milky Way is that nothing is standing still. Everything is drifting, everything is flowing. Just as the Earth orbits the Sun orbits the center of the galaxy. Our entire solar system is moving through space at a speed of about 800,000 kilometers per hour. But the galaxy is so huge that even at this blazing speed it takes us a very long time to complete one lap. We call this a galactic year, or a cosmic year. One galactic year is about 225 to 250 million Earth years. To give you a sense of scale, let's look at the last time we were in this exact spot in the galaxy. The last time our solar system was here, humans did not exist. The mammals did not exist. The flowers had not yet evolved. The dinosaurs were just beginning to appear on the Earth. We have travelled all the way around the galaxy, a journey of 160,000 light-years, just to get back to where the dinosaurs started. That is the scale of the clock we are living on. Because everything is moving, the stars are not fixed in place forever. The constellations you see at night, the Big Dipper, Orion, the Southern Cross, are temporary. They are just a snapshot of where our neighbours happen to be right now. If you could fast forward time by 1 million years, the night sky would look completely different. The familiar shapes would be twisted and gone, replaced by new patterns as stars drift apart. This brings us back to the wanderers like 3i Atlas. In this massive swirling disk of stars, gravity is constantly stirring the pot. Sometimes a star will pass close to another star. They don't usually crash, but their gravity tugs at each other. This can shake up their outer edges. Our Sun has a shell of icy comets around it called the Oort cloud. Other stars have the same thing. When stars drift past each other in the spiral arms, they can knock these loose comets free. Imagine walking through a crowded market. If you bump into someone, something might fall out of their bag. That is what happens in the galaxy. A star passes by and a comet gets knocked loose. It floats through the empty space between stars for millions of years, drifting in the dark until perhaps it falls into a new system, just like 3i Atlas fell briefly into ours. We are not sitting in a static room looking out a window. We are on a raft floating down a wide spinning river. The scenery is always changing. The stars we see today are our travel companions for this leg of the journey, but they will not be with us forever. This perspective helps us understand why we must keep watching the sky. We are drifting through a busy sea of traffic. Most of the traffic stays in its lane, but occasionally something crosses our path. It reminds us that Earth is not an island isolated from the universe. We are an active participant in the galactic ecosystem. We are made of the same material as those distant stars, moving to the same gravitational rhythm, circling the same dark heart in the distance. So when we look up at the band of the Milky Way stretching across the dark sky, we are not just looking at outer space. We are looking at our own body. We are looking at the structure that gave birth to our sun, and eventually to us. We are a small blue speck in the Orion Arm, quietly circling the city lights, trying to understand the traffic that flows past our door. The great galactic neighbours. As we leave the familiar spiral arms of the Milky Way looking back at our home galaxy, it might feel like we have left everything behind. But in the grand scheme of the universe, we have merely stepped out of our house and into our front yard. We are not alone in the dark. In fact, we are in a very crowded room, surrounded by ancient giants and rushing forces that dwarf human imagination. The first thing that grabs your attention is a smudge of light in the distance. To the naked eye on Earth, it looks like a fuzzy star, but out here its true shape is undeniable. This is Andromeda, also known to astronomers as Messier 31. It is our big sister. While the Milky Way is massive, Andromeda is even larger, containing perhaps 1 trillion stars compared to our 200 to 400 billion. And here is the most startling reality about our neighbour: she is coming for us. In a universe where most things are moving away from each other due to the expansion of space, Andromeda and the Milky Way are locked in a gravitational embrace. We are falling toward each other at a speed of roughly 110 kilometers per second. That is fast enough to travel around the entire Earth in just a few minutes. For the next 4 billion years, this gap will close. Eventually, the two galaxies will meet. But do not imagine a violent crash like two cars hitting head-on. Galaxies are mostly empty space. When they collide, it is very unlikely that individual stars will hit each other. Instead, they will pass through one another, dancing a chaotic gravitational waltz. The spiral arms will be torn apart, flung out into long tails of gas and dust. Eventually, the two cores will merge, settling down to form a single massive oval-shaped galaxy, often nicknamed Milkomeda. It is a violent yet beautiful destiny. It is a reminder that even galaxies which seem eternal and unmoving to us are actually living, dying, and evolving creatures. Our galactic village, the local group together the Milky Way. Andromeda and a smaller spiral galaxy called Triangulum form the big three of our neighbourhood. But we are not just a trio. We are accompanied by more than 50 smaller dwarf galaxies. These small clusters of stars orbit the big galaxies like moths circling a street lamp. You might know the Large and Small Magellanic Clouds. These are two of our closest satellite galaxies slowly being digested by the Milky Way's gravity. Astronomers call this entire collection the local group. Think of the local group as our village. It spans about 10 million light-years across. In this village, gravity is the mayor. The gravity between the Milky Way and Andromeda is strong enough to overcome the expansion of the universe holding our group together while other distant groups drift away. This is our safe harbour in the cosmos. No matter how much the universe expands in the distant future, the local group will stay together. When the rest of the universe disappears beyond the horizon of visibility billions of years from now, the stars of the local group will be the only friends we have left. The great rivers of gravity, Laniakea. If the local group is our village, where is our country? For a long time, astronomers thought we were just an outlier of a massive collection called the Virgo Cluster. The Virgo Cluster is huge, containing thousands of galaxies. We are being pulled toward it. But recently we realized that both our local group and the Virgo Cluster are just tiny parts of something much, much bigger. We live in a supercluster called Laniakea. The name means immeasurable heaven in the Hawaiian language. It is a fitting name. Laniakea is a structure so vast that it is hard to comprehend. It stretches over 500 million light-years. It contains the mass of 100,000 galaxies like ours. But Laniakea is not defined just by its shape. It is defined by movement. Just as water flows down mountains into valleys, eventually reaching a river, galaxies flow through the universe. In Laniakea, all the galaxies ourselves, Andromeda, the Virgo Cluster, are flowing like a cosmic river toward a central point. This central point is a gravitational anomaly known as the Great Attractor. We do not know exactly what the Great Attractor is because it is hidden behind the dust of our own galaxy, but its pull is undeniable. It is the downtown of our supercluster city pulling everything toward it. Seeing this flow on a map changes your perspective. We are not stationary. We are caught in a current of gravity drifting along with millions of other galaxies in a river of starlight. The cosmic web, threads of light in the dark. Now, let us pull the camera back as far as it can go. Let us look at the universe not as a collection of stars, but as a single structure, When you zoom out this far, the universe looks surprisingly familiar. It looks like the neural network of a human brain, or the pattern of a spider's web, or the roots of a giant tree. This is the cosmic web. The universe is not random. It is organized into vast glowing threads called filaments. These filaments are made of dark matter, gas and galaxies stringing together like pearls on a necklace. This is where most of the universe's ordinary matter lives. Our supercluster Laniakea is just one bright knot in one of these filaments. Between these filaments, however, lies the true terror and majesty of the cosmos, the voids. These are the empty spaces in the web. They are colossal bubbles of nothingness. One of the most famous is the Bootes void, also known as the Great Nothing. It is nearly 330 million light-years across. If the Milky Way were in the centre of the Bootes void, we would not have known other galaxies existed until the invention of telescopes in the 1960s. In these voids, there is almost nothing, very few stars, very little gas, just cold, dark, expanding space. They make up the majority of the universe's volume. The cosmic web, therefore, is a delicate structure of light wrapping around vast bubbles of darkness. Dust and divinity, standing here looking at the cosmic web, the feelings is overwhelming. When we looked at the solar system, Earth seemed like a significant rock. When we looked at the Milky Way, our sun seemed like one meaningful grain of sand. But here, looking at the cosmic web, our entire galaxy, our home of hundreds of billions of stars, is reduced to a single pixel of light, a tiny speck of dust caught in a gravitational wind. It is easy to feel crushed by this scale. It is easy to feel that we are accidents, insignificant errors in a machine too big to care about us. But there is another way to look at it. Look at the connections. The cosmic web shows us that nothing is isolated. The gravity that pulls Andromeda toward us is the same gravity that holds your feet to the ground. The atoms in your body were forged in the stars that make up these filaments. We are not separate from this web. We are made of it. We are the way the universe experiences itself. In the middle of the vast voids and the crushing gravity on a small rock circling of a small star, the universe grew eyes and looked back at itself in wonder. The local group is our family. Laniakea is our home. The cosmic web is our body. We are small, yes, but we are also part of the greatest structure in existence. We are the dust that woke up and learned to dream. For as long as humans have stood upright and turned their eyes toward the night sky, we have been haunted by a single overwhelming question. It is a question that sits at the very center of our existence, echoing through our history, our science and our dreams. Are we alone? When we look up, we see a canvas that seems infinite. We now know that our galaxy, the Milky Way, contains somewhere between 200 billion and 400 billion stars. And beyond our own neighborhood, there are potentially 2 trillion other galaxies in the observable universe. The numbers are so large they become almost impossible to truly understand. If you were to count every single grain of sand on every beach on Earth, you would still not have a number equal to the stars in the cosmos. Logic suggests that with so much real estate, so much energy and so much time, roughly 13.8 billion years, life should be everywhere. The universe should be noisy. It should be teeming with signals, ships, megastructures, and the chaotic radio chatter of a million civilizations. And yet when we point our telescopes at the stars, when we listen with our most sensitive radio dishes, we hear nothing. Only the static hiss of cosmic background radiation. Only the sound of dying stars and spinning pulsars. This is the great silence. This contradiction is known as the Fermi paradox. It is named after the physicist Enrico Fermi, who during a casual lunch conversation about aliens simply asked, "Where is everybody?" It is a simple question with terrifying implications. If the universe is so old and so vast, civilizations older and more advanced than us should have arisen millions of years ago. Even at slow speeds, a spacefaring civilization could colonize an entire galaxy in a few million years, a blink of an eye in cosmic time. But we see no one. We hear no one. The silence is deafening. This brings us back to 3i Atlas. When this object pierced our solar system, it offered a momentary flicker of hope, or perhaps fear, that the silence had finally been broken. For decades we assumed the first contact would be a radio signal, a mathematical sequence beeped across the void. We did not expect a silent visitor. 3i Atlas behaved strangely. It moved with a speed that defied the normal gravity of the sun. It tumbled in a way that felt unnatural. For a brief moment, the entire world held its breath. Was this it? Was this the hull of a derelict spacecraft? Was it a probe sent to scan us? Was it a message in a bottle cast into the cosmic ocean billions of years ago, finally washing up on our shores? Or was it just a rock? This uncertainty is where the true weight of the Fermi paradox hits us. If 3i Atlas was just a piece of ice and stone, a mindless fragment of a destroyed planet, then the silence continues. It means we are projected back into our isolation. But if it was artificial, even if it was dead and broken, it changes everything. It proves we are not the first to think, to build, and to travel. However, the silence of the universe forces us to confront the great filter. This is the theory that there is some barrier, some insurmountable hurdle in the development of life that prevents civilizations from surviving long enough to say hello. Maybe the filter is behind us. Maybe life itself is incredibly rare, a miracle that happened only once on a wet blue rock. In this scenario, we are the first. We are the elders of the universe, destined to fill the silence ourselves. Or more frighteningly, maybe the filter is ahead of us. Maybe civilizations rise all the time, but they inevitably destroy themselves once they discover nuclear power or artificial intelligence or biotechnology. Maybe the silence exists because advanced societies burn brightly for a few centuries and then extinguish themselves, leaving behind only ruins and drifting rocks like 3i Atlas. There is also a darker possibility, one that science fiction writers often whisper about. Perhaps the universe is not silent because it is empty, but because it is dangerous. Perhaps there are things in the dark and wise civilizations know to keep quiet. In this view, our constant broadcasting of radio waves and television signals into space is like a baby crying in a dark forest filled with predators. If 3i Atlas was a probe, maybe it wasn't a greeting, maybe it was a scout. But why does this matter so much to us? Why do we spend billions of dollars building ears to listen to the sky? It is because the human heart struggles with the concept of infinity, but it struggles even more with the concept of isolation. We are a social species. We define ourselves by our connections to others. We have families, tribes, nations, and communities. To imagine that we are the only conscious minds in a universe spanning billions of light years is a crushing weight. It makes our wars seem petty and our struggles seem meaningless. If we are the only ones here, the responsibility is too great. We become the sole custodians of meaning in the universe. We look for 3i Atlas to be a ship because we want a reflection. We want to know that someone else made it through the filter. We want a big brother in the stars to tell us that it is possible to survive our own adolescence as a species. We are looking for a kinship that transcends biology. We are looking for someone to share the burden of existing. If 3i Atlas is just a rock, a tumbleweed of the void, it serves as a cold mirror. It reminds us that the universe does not care about us. The universe is vast, cold, and largely dead. It suggests that consciousness, the ability to love, to wonder, to create art, is a fragile, flickering candle in a hurricane. There is a famous quote that sums up this anxiety perfectly. Two possibilities exist: either we are alone in the universe or we are not. Both are equally terrifying. If we are not alone, we face the unknown. We face potential threats or civilizations so advanced that we are like ants to them. We face the reality that we are not the center of creation, but merely one average planet among trillions. But if we are alone, that is a specific kind of horror. It means that if we destroy ourselves, if we let our planet die, the universe goes back to being blind and dumb. It means the music stops. It means the art, the history, and the love that we have created vanishes forever with no one left to remember it. So we continue to watch objects like 3i Atlas. We analyze their trajectory, their composition, and their speed. We argue over data points and run computer simulations. We do this not just for science, but for hope. We are searching for a friend in a room that has been dark for 13 billion years. Whether 3i Atlas was a greeting or a stone, the fact that we are looking says more about us than it does about the object. It proves that we refuse to accept the silence. We refuse to accept that the stars are just nuclear fireballs. We insist on finding meaning. Perhaps the great silence is not a wall, but a door. Perhaps it is waiting for us to become loud enough, wise enough, and brave enough to walk through it. Until then, we watch the skies, holding on to the hope that the next visitor or the next signal will finally answer the question, is anybody out there? For now, the answer remains the same. The universe is vast and it is silent, but we are here and we are listening. As we come to the end of our long journey together, I invite you to find the most comfortable position in your bed. Let your shoulders drop away from your ears. Unclench your jaw, let your hands rest gently by your sides. We have travelled millions of miles through the dark, cold vacuum of space following the path of Comet Atlas. We watched it dance near the sun, and we watched it break apart. But tonight, for this final chapter, we are not looking out there anymore. We are looking right here. We are looking at you. Take a deep, slow breath. Inhale the cool air of the night and exhale the warmth of your body. Think back to that comet one last time. When it shattered, it didn't disappear. It turned into a cloud of dust and ice. It became a shimmering stream of particles. In the vastness of space, nothing is ever truly lost. It only changes form. It changes shape. This brings us to this most beautiful secret of the universe. It is a secret that connects you to Comet Atlas, to the sun, and to every single light you see in the night sky. The secret is this: you are made of stardust. This is not just a poetic idea. It is a scientific truth. Every ingredient that makes up your body was cooked inside the fiery hearts of ancient stars. Imagine a time long before the Earth existed. Billions of years ago, space was filled with giant stars. These stars were like cosmic kitchens. Inside them, it was incredibly hot and dense. For millions of years, these stars worked hard. They took simple atoms like hydrogen and crushed them together. They were cooking. They cooked up the carbon that is now in your muscles. They cooked up the calcium that is now in your white bones. They cooked up the iron that makes your blood red. And they cooked up the oxygen that fills your lungs right now as you breathe in and out. When those giant stars grew old, they did not just fade away. They gave a final magnificent gift to the universe. They exploded. These massive explosions scattered all those precious ingredients far and wide across the galaxy. Picture that dust floating in space. It is glittering and beautiful. It looks like a cloud of gold and silver mist. Over millions of years, gravity, that gentle invisible hand, pulled that dust together. It pulled the dust into rocks. It pulled the rocks into planets. It formed our Earth. And eventually from that same ancient dust, life began. And from that life came you. So as you lie here tonight, safe under your blankets, remember that you are not separate from the universe. You are not a stranger here. You are the universe. You are a piece of the cosmos that has come alive to look at itself. Feel the weight of your body pressing down into the mattress. That weight is gravity holding you. It is the same force that holds the moon in the sky and the planets in their orbits. You're grounded. You're held. You're safe. Think about your left hand. Wiggle your fingers gently. The atoms inside those fingers have travelled billions of miles to be there. They have seen the birth of suns. They have floated through nebulas. Now they have come together to form you. They have travelled all that way just to let you feel the softness of your sheets and the warmth of your bed. Everything moves in a circle, a cycle. Just like the comet returns to the deep dark and the water rain falls and returns to the ocean, the matter in the universe cycles forever. The water you drink is the same water that dinosaurs drank millions of years ago. It is the same ice that floats in the rings of Saturn. The air you breathe is the same air that has circulated around this planet for eons. We are all borrowing these atoms. We are borrowing this stardust for a little while, shaping it into a life, into a memory, into a dream. Does that not make you feel eternal? You are much older than the years you have lived. The essence of you is as old as time itself. There is a deep peace in knowing this. You do not have to worry about being small. You do not have to worry about the future. You have been part of this universe since the very beginning, and you will be part of it until the very end. You belong here. You fit perfectly into the puzzle of existence. Now let that feeling of belonging wash over you like a warm wave, from the top of your head down through your neck into your chest and down to your toes. Imagine you are floating in that vast, quiet space again. But it is not cold. It is warm and comfortable. You are floating in a sea of ancient stars. You are weightless. Around you, the stars twinkle slowly. They are like nightlights watching over you. They are your ancestors. They are your family. There is no noise here, no rush, no deadlines, no worries, just the slow rhythmic breathing of the cosmos. In and out, in and out. You are drifting on a river of time. The comet has finished its journey, and now your day has finished its journey too. It is time to rest. It is time to let the stardust settle. Let your mind drift away from the words I am speaking. Let them become soft sounds like a gentle breeze outside your window. You are safe in your bed. You are safe in your home. And you are safe in this galaxy. The universe is big, yes, but it is not empty. It is full of the same stuff that makes you you. Everywhere you look, you see a reflection of yourself. The iron in the meteor is the iron in your blood. The calcium in the rocky moon is the calcium in your teeth. We are all one thing. We are all connected. There is no separation. There is only peace. So close your eyes. Let the darkness behind your eyelids become the velvet darkness of space. Let the silence of the room become the peaceful cadence of the stars. You have done enough today. You have travelled far enough. Now it is time to recharge. It is time to let your atoms rest. Rest now, traveller. Rest now, child of the stars. The universe is holding you. The night is wrapping its arms around you. You are loved, you are ancient, and you are home. Sleep now, deep, peaceful sleep. Good night.